Hello, welcome to this OMG revision video. Today we're going to be taking a quick look at the climate change topic, which forms part of the weather hazards and natural hazards unit from paper 1. So in the description is a link to the worksheet, or you can grab a worksheet from room 5. This particular one has all of the different aspects of climate change, so the evident causes, impacts, and then management, including mitigation and adaptation. And this version of the worksheet has dual-coded images to help with your retrieval practice, your memory. However, if you want to give yourself a challenge, or you've already completed the dual-coded version and you're getting closer to exams and you want an extra challenge, then have a go at the non-dual-coded version, so just the words and you adding your knowledge to those words. So have a go at either sheet. The link in the description will take you to both of those, and in this video we're just going to run through a little bit of information about the answers and the climate change topic. So starting off with pollen analysis. So pollen that's found in fossils, think of that Steven Spielberg film Jurassic Park, can show us what types of plants grew millions of years ago and give us clues about the climate. Importantly, that is a form of long-term evidence for climate change since the beginning of the Quaternary period, 2.6 million years ago. So you might be asked for that long-term evidence all the way back to the start of the Quaternary period, 2.6 million years ago, or you might be asked for short-term evidence in the present day. Another example of long-term evidence is ice core analysis. So scientists can measure the amount of CO2 and other gases in an ice core taken from an ice cap on planet Earth to find out what climate was like in the past based on the composition or the makeup of different gases. Some of the ice cores in Antarctica can give us information about what the climate was like up to 800,000 years ago. That is also a long-term piece of evidence for change since the Quaternary period, or during the Quaternary period. Moving on to our short-term evidence, so we have melting ice caps as a result of the higher global temperatures, which we sometimes refer to as global warming. Arctic sea ice is 65% thinner than it was in 1975. We lost about 75% of summer sea ice since the 1970s. So melting ice caps give us, in the present day, really short-term evidence that climate change and global warming is happening. Next, thermal expansion. So warmer water is deeper as it expands. So as global warming occurs, ocean temperatures increase and sea levels rise. And thermal expansion, so the expansion of the water due to the hotter temperatures, is thought to account for up to about a third of sea level rise, with the rest being from melting. And then rising sea levels. So melting ice caps and thermal expansion have caused sea levels to rise between 10 and 20 centimetres in the past 100 years, and that trend is set to continue, if not grow increasingly. So those three, melting ice caps, thermal expansion and rising sea levels, are short-term evidence that we can look at today that give us information about how the planet has changed in the last few decades to the last century. Okay, moving on to the causes of climate change, so the use of fossil fuels, particularly burning them. So thinking of coal, gas and oil here, including petrol, release carbon dioxide into the atmosphere that contributes to the enhanced greenhouse effect. Somewhere around 37 billion tonnes of carbon gets released annually by the human race, which is a rate that has doubled since the 1970s, so that enhanced greenhouse effect is becoming exponentially stronger. Agriculture as another cause of climate change, particularly animal agriculture, so cattle or cow farming, which we learned about in the Amazon rainforest as a cause of deforestation, is releasing methane into the atmosphere, but also the deforestation required to make grazing land is also releasing carbon, as trees are a carbon sink. But methane, particularly from cattle farming, is 25 times more potent than carbon dioxide, which is going to speed up that enhanced greenhouse effect. So the more we as countries around the world develop and consume meat, particularly cattle, that's going to drive up both the carbon dioxide and methane emissions. Next, deforestation. So trees absorb and store CO2. We call them a carbon sink. The rainforests, but all forests around the world, For example, the taiga or boreal forest in Scandinavia and Northern Europe are all carbon sinks. So when we cut down these carbon sinks, these trees, all of that carbon that is locked up and stored in them is released into the atmosphere, again contributing to the enhanced greenhouse effect. Then moving on from our human causes, so the things that people do, onto the natural causes of climate change over the Quaternary period. One of the biggest causes of natural climate change is orbital changes, so changes in the Earth's orbit around the Sun. That orbit changes usually in cycles around about 10,000 years, and that means that at some points the Earth is slightly closer, or the Earth's orbit is slightly closer to the Sun than others. So the cycles are called eccentricity, precession and tilt. The one we learn most about is eccentricity. Those three are known as the Milankovitch cycles. So the scientist that discovered them, Milankovitch, talked about eccentricity as essentially the shape of the Earth's orbit. Sometimes it's more circular, sometimes it's more elliptical. That affects how much radiation from the Sun the Earth is receiving, and decides whether we are in glacial periods, so cold periods, ice ages you might know them as, or warmer interglacials, which are the warmer periods where we don't have any ice on the North and South Pole. Next natural cause of climate change is volcanic activity. So when a volcano erupts, the ash particles act like tiny mirrors and block out the sun's solar energy or insolation, resulting in global cooling. So the pieces of volcanic ash act like little bits of glass, refracting and reflecting sunlight, meaning that less sunlight gets to Earth's atmosphere and into the atmosphere, resulting in cooler temperatures, sometimes called a volcanic winter. Next, solar changes or solar activity, particularly related to sunspots, which are those spots that you might see on telescopic images of the Sun. When there's more sunspots, the Earth's temperature increases as more insolation is being radiated from the Sun. Okay, the impacts of climate change. So those are the causes, what's driving this change, and how does that impact people, the environment and the economy. Well, the first one is increased temperatures. Since 1880, global temperatures have increased by 1 degree Celsius, and different parts of the world are experiencing that at different rates. So for example, the Arctic is the fastest warming place on Earth. Also increased frequency and intensity of drought. So climate change has led to the risk of drought, which is a prolonged period without rainfall, so a very dry period, 20 times higher. Again, that varies around the world, with some of the most intense droughts being around the equator and in the tropical regions. However, drought is something that affects countries as far away from the equator as the UK. Flooding of low-lying land is another impact of climate change. So low-lying land such as coastal areas of Vietnam, but we also see this effect in London with the Thames Barrier being used to combat this, lead to a higher risk of flooding due to rising sea levels. Also, another impact is that tropical storms will be distributed further away from the equator. So a larger percentage of the ocean will be at that 27 degrees Celsius ocean temperature, and that means that tropical storms will start to form further north and south of the equator than the 5 to 15 degree band that they currently form in. So perhaps that band will become all the way from 5 to 20 degrees north and south of the equator. Tropical storms are also becoming more frequent, so scientists believe that the number of tropical storms could increase as global ocean temperatures increase. And finally, global tropical storms are becoming more intense. So a lot of scientists believe that the intensity, magnitude or strength of tropical storms could increase, with more category 4 and 5 storms occurring. Okay, and finally, moving on to managing climate change. So it's important to highlight that there are two methods of managing or mitigating the effects of climate change. Mitigating just means making them less bad. So when we talk about mitigation, we're talking about strategies that reduce or get rid of the root cause of climate change, which is greenhouse gases. So if there are any strategies that reduce the use of greenhouse gases or replace the use of greenhouse gases or activities that produce them, we'd call those mitigation. Whereas adaptation is all about changing our lives to cope with the effects of climate change in order to maintain our quality of life. So those adaptation strategies aren't going to stop climate change, they're not going to reduce the amount of greenhouse gases in the air, but they will help people to adapt their lives and manage their quality of life. Generally, mitigation strategies are more expensive, so tend to be more suited to LICs that have enough income or GDP to invest in those strategies, and generally adaptation strategies are cheaper and therefore more suitable for low-income countries. However, it is up to all nations in the world to collaborate so that we can all take part in effective adaptation and mitigation. Sounds like a good conclusion to a 9 marker to me. So, looking at our mitigation strategies, so a reminder, these are the ones that are going to remove greenhouse gases. The first one is alternative energy production. So renewable energy sources such as wind power and solar energy do not have CO2 emissions, and that could reduce the rate of climate change as we're not putting those greenhouse gases into the atmosphere. So I had a look at the UK's energy mix today on the National Grid website. We are getting about 40% of our energy and electricity from renewable sources. Today is quite a warm day, so about 27% of that is from solar energy and about 12% from wind power. But in colder, wintry months, we tend to get more from wind power, but today is just a particularly sunny day. Carbon capture. So these involve facilities that capture carbon in processes it's released, so industrial processes, but also energy development. So 90% of carbon released from burning coal can be captured, and that's piped to storage reservoirs underground where it becomes a form of rock, which reduces the risk of climate change. So a good example of that is the Orca facility in Iceland. Afforestation, as we mentioned before, trees are a carbon sink, so they absorb and store carbon dioxide. So by planting them, or afforestation, we can basically do a very, very cheap form of carbon capture. The best example of this is the Great Green Wall across Africa, from West Africa to East Africa, coast to coast. And then finally, international agreement. So the Intergovernmental Panel on Climate Change, or IPCC, in partnership with the UN, provide governments with scientific evidence to help countries reduce their emissions and slow down climate change. And countries can come to agreements, as they did at the Paris Climate Agreement in 2015 and COP26 in Glasgow in 2022, to take the necessary actions to keep global warming and global temperature increase to below a certain number. So the current aim is to keep it to stop warming from going any higher than 2 degrees Celsius above pre-industrial levels. Finally, our adaptation method. So how can people change their lives? The first one, we're looking at changes in agricultural systems. So farmers can be educated on new methods of farming, such as use of drought-resistant crops, which is something that has taken place in the Gambia in Africa. We can also manage water supply as well, so think really carefully about how we use water. So using intermediate technologies such as sand dams in Makueni County in rural Kenya. We can help people in poverty to reduce the impacts of drought by learning to sustainably store and use fresh water. And finally, reducing the risk from rising sea levels in Vietnam and other Southeast Asian countries like Indonesia. So you would have learnt about houses called kampungs in year 7. People have built their houses on stilts to adapt to coastal flooding. Other places have used coastal defences, such as seawalls, which we learnt about at Lyme Regis. So that is an overview of the climate change topic using this dual coding resource. So once you've green penned your answers, don't forget to come back to it a second time. If you use the dual coded version, perhaps try next time using the non-dual coded version. But if you still need to beat your confidence, there's absolutely no problem with you using the same resource again. That's everything for this video. Have a great revision session.